the previous session, in the previous lecture, we had started our new chapter, that is electricity. Fine. In that chapter, we had discussed about electric charge, electric current, the direction of electric current. Fine. And the number of electrons present in 1 coulomb of charge, right? And some of the numericals, right? Let's recall the formulas that we had done in the previous lecture. That is, according to the quantization of charge, Q is equals to, according to the quantization of charge, Q is equals to Ne, right? Is that clear, everyone? Q is equals to Ne. I is equals to Q upon T, means current is the rate of flow of charge, right? And the value of Q is Ne, so I becomes Ne upon T, right? After that, we had done about the direction of electric current. The direction of electric current is from positive terminal to the negative terminal, right? From positive terminal to the negative terminal. That is always opposite to the direction of flow of electrons, right? Always opposite to the flow of electrons, right? So today we are going to discuss the concept of electric potential, then potential difference, right? After that, some circuit symbols, right? So first of all, electric potential is denoted by symbol V, capital V. Fine. So what is electric potential? Electric potential at a point in an electric field is the ratio of work done in bringing a unit positive charge from infinity to that point. Fine. Or you can say electric potential at a point in an electric field is the work done in bringing a unit positive charge from infinity to that point. Don't write ratio. Fine. Is the work done in bringing a unit positive charge from infinity to that point. So according to the definition, electric potential is actually work done per unit charge, per unit positive charge. Fine. So the formula becomes V is equals to W upon Q, where W is the work done in bringing that unit positive charge from infinity to that, right? Electric potential, electric potential is a scalar quantity. Fine. And the SI unit of electric potential is volt. Fine. So the SI unit of electric potential is volt denoted by capital V. Clear? So I'm repeating again. Electric potential at a point in an electric field is work done in bringing a unit positive charge from infinity to that point. Work done upon charge, ratio of work done to the charge, right? From infinity to that point. Electric potential is a scalar quantity, means it does not depend upon the direction. Fine. Third is SI unit of electric potential is volt, denoted by symbol V, capital. Right? After that, we have one more term that is known as potential difference. Now, what is potential difference? There is a little difference between electric potential and potential difference. Now, how can we define potential difference? Potential difference between 2 points. Here we're talking about two finite points. Potential difference between 2 points in an electric circuit in an electric circuit is defined as the work done in bringing unit positive charge from one point to another. Fine. It is work done in bringing a unit positive charge from one point to another. In this, we have infinity to that point. This is the difference between electric potential and potential difference. So according to the definition, again, potential difference is denoted by V. Fine. So it is again work done per unit charge. Work done in bringing unit positive charge from one point to another. So work done upon charge. SI unit is SI unit is volt, denoted by symbol, right? Now suppose you have 2 points, point A and point B. Fine. So charge is moving from point A to B. The positive charge is moving from point A to B. In this case, you will write VB minus VA is W upon Q. The difference in the potentials of these points. So VB minus VA is equals to W upon Q. Fine. So suppose if the potential at A is 10 volt, at B is 20 volt, then the potential difference, it becomes 20 minus 10 is W upon Q. That becomes 10. So 10 is the potential difference between A and B. Remember this. Fine. Now, how can we define the SI unit of potential difference? Means to say SI unit is volt only. How can we define this volt? We know that SI unit of work is joule, and for charge it is coulomb. Means V is equals to joule upon coulomb. How to define it? Just put 1 means you have to make it unit, right? 1. So how can we define the potential difference? It's said to be The potential difference is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb of charge from one point to another. So how to define? Potential difference is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb of charge from one point to another according to the definition. Fine. Work should be 1 joule and the charge is 1 coulomb. In that case, the potential difference becomes 1 volt. This is how to define a unit. Right? This is how you can define a unit. Right? After that, potential difference potential difference is measured by a device called voltmeter. Fine. We have a device called voltmeter, fine, by which we can measure the potential difference. Right? The symbol of voltmeter is V, right? Circle, and V positive, negative. Is that clear, everyone? Is that clear, everyone? This is the concept of potential difference. Fine. Let me repeat the concept of electric potential and potential difference again, starting with electric potential. Electric potential at a point in an electric field is defined as the work done in bringing a unit positive charge from infinity to that point. Right? So work done to the charge. W upon Q is the formula of electric potential. Electric potential and potential difference, they both are scalar quantities. Right? So SI unit of electric potential is volt. Now, if you talk about potential difference, in this case, we are talking about 2 points. Fine. The potential difference between 2 points in an electric circuit is defined as work done in bringing unit positive charge from one point to another. Fine. For example, from A to B. So in this case, potential difference is work done upon charge again. SI unit is volt again. How to define the unit of electric potential or the potential difference? The potential difference is said to be 1 volt is equal to the potential difference is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb of charge from one point to another. Right? So that's why 1 volt is 1 joule upon 1. Fine. And the device which is used to measure the potential difference, that is known as voltmeter. Right? That is known as voltmeter. Clear, everyone? Right. So next is electric circuit and its components. So what is electric circuit actually? An electric circuit and electric circuit consists of a source of power. It can be a cell or battery. Fine. Switches. Fine. electrical components, electrical components and connecting wires. Fine. So electric circuit consists of a source of power which can be a cell or a battery, switches, fine, electrical components, fine, and the connecting wires. Clear? So this is known as electric circuit. Fine. We have different electrical components. Fine. So for example, starting from the first point, that is electric cell. Fine. Cell is denoted by symbol a positive and a negative plate. Fine. Positive and negative. Fine. So its function is to provide potential difference or the voltage. Right. Second one is a battery. But when number of cells are connected, in that case it becomes battery. Function is same, to provide potential difference to an electric circuit, right? After that, plug key or switch. Open switch. Open switch is denoted by symbol this. Switch is open means current is not flowing through the circuit, right? That is switch off. Fourth one is again plug key or switch closed. Switch closed means the current is flowing through the circuit. Fine. And thus we have a dot between these two. Right. Now, next is fifth one is a wire joint. Means two wires are joint. This is how you can represent a joint wire. Right. Next one is wires crossing without joining. Means the wires are not joining, they are crossing on. Fine, they are not joined. Right. Next is electric bulb. It is represented by symbol this, electric bulb. Right. Next, that is a resistor. Symbol is this. This is known as fixed resistor. Actually, fixed means its resistance will not vary. This is known as resistor that resists the flow of charge, which provides the opposition to the flow of charge. Right. Next one is variable resistor. Variable resistor or rheostat. Fine. Variable resistor means here is the resistor, draw an arrow. Fine. This becomes variable resistor or it is represented by symbol this, variable resistor or the rheostat. Right. Next is Ammeter, denoted by symbol A. Yes, of course, yes. Ammeter, which denotes electric current. To measure electric current, we have a device called ammeter, denoted by symbol A. Fine. Next one is voltmeter, denoted by symbol V, which measures the potential difference. Which measures potential difference. Right? And the last one is called galvanometer, denoted by symbol G. Galvanometer. Fine. Which gives the direction of electric current. Which gives the direction of electric current or the presence of electric current, right? So these are some circuit symbols, fine, or the electrical components, fine, which we will use in the further topics, fine. So electric circuit, it consists of a source of power like battery or cell, switches, some electrical components, fine, and the connecting wires. When if you talk about electrical components, we have different electrical components, fine. Electric cell, denoted by a positive and a negative plate, fine, which provides the potential difference or EMF, fine. Battery, again, if you have number of cells, they are connected together, fine, it becomes battery, fine, function to provide the potential difference across the circuit. Third one is plug key or switch. If you talk about open switch, fine, means current is not flowing through the circuit. In that case, we will draw this on. If we have a closed switch, means the current is flowing through the circuit, then we have to draw a dot between these two. A wire joint, when want to draw when you want to draw a joint, in that case we have to draw like this, a point where the wires are joining, fine. If you talk about a crossing wire but they are not joining, in that case we have to draw it like this, fine. In that, this means wires are like this, they are not joined like this, they are crossing, fine. And next one is electric bulb, or you can say lamp, fine. Symbol is this. Fixed resistor uh, is that component which opposes the flow of charge in the circuit, right? Next is variable resistor. Variable resistor whose resistance may vary, fine. It is the resistor whose resistor we can change, that is known as a variable resistor or the rheostat, fine, denoted by a resistor with an arrow, fine, or the symbol, right? Next is ammeter. Ammeter is the device which measures electric current, fine. Next is voltmeter, denoted by symbol V, fine, which measures potential difference or the voltage, fine. Last one is galvanometer. Galvanometer denotes the direction, that gives the direction of electric current, or it is used to find which gives the presence of electric current in the circuit, right? So these are some circuit symbols with their description, fine. So one of the most important part of this chapter, that is electric circuit and its components. Is that clear, everyone? Great. Right. So let's move to the next topic. One of the most important topics of this chapter, that is known as Ohm's law. You're not audible. Can you please repeat again? It's Ohm's law. OHM. Ohm's law. Fine. Uh, a scientist, George Simon Ohm. Fine. He was a German physicist. Actually, he studied the relationship between the potential difference across the conductor and current through it. Fine. So actually, he gave the relationship between the potential difference, that is V, and current I. The relationship between potential difference and current is known as Ohm's law. Fine. Now, Ohm's law states that Ohm's law states that the potential difference across the two ends of the conductor is directly proportional to the electric current flowing through the conductor, provided physical conditions remain same. Fine. According to the law, the potential difference, that is V, across the two ends of the conductor is directly proportional to the electric current. Potential difference is directly proportional to the electric current, provided physical conditions remains in. Physical conditions means like temperature, density, like this. Means conductor's temperature or the density remains same. Fine. In that case, the potential difference is directly proportional to the current. Means when you increase the potential difference, the current will increase. If you decrease the potential difference, in that case, the current will decrease. So they both are directly proportional, right? So we know that whenever we need to put equality instead of proportionality, we have to apply a proportionality constant, right? Here, the proportionality constant is R, fine, where R is called proportionality constant called resistance. Fine, this R is known as resistance. R becomes V upon I. Clear? So according to the relation, R is constant. Fine. So if you draw a graph between V means potential difference and current, it should be a straight line. This straight line means the slope will give you resistance. If it is a straight line, it represents constant resistance. I'm repeating again. George Simon Ohm, he studied the relationship between potential difference across the conductor and current through it. Fine. Uh, in I guess 1827. Fine. You will not write this. Fine. We need only the statement of the law. Ohm's law states that potential difference across the two ends of the conductor is directly proportional to the current flowing through. Right? V is directly proportional to the I. Now, if we talk about a small battery of 9 volt, it has two terminals, positive and negative. You can easily touch the both terminals because the voltage is less, so that the current is very less in that case. Fine. So if we talk about the switches in which we have 220 to 240 volt, fine, we can't touch the switch, fine, with this voltage, because if the voltage is more, in that case the current is more, fine, it will harm. So potential difference is directly proportional to the current, means if the voltage is more, in that case the current will be more. Fine. Proportionality, then equality. If you put equality instead of proportionality, we have to apply a proportionality constant. In this case, the proportionality constant is R. So R becomes V upon I. Fine. If you cross multiply it, it becomes V upon I. Right? So V is directly proportional to I, means when you increase the potential difference, the current will increase. So it will give you a straight line that represents the constant resistance. Is that clear, everyone? Is that clear, everyone? Okay, let's define this concept, that is resistance. Fine. Resistance is the opposition offered by the conductor to the flow of charge. Fine. Resistance is the opposition offered by the conductor to the flow of charge. Fine. It is the property of the conductor to oppose the flow of charge. Right? The SI unit of resistance is ohm. Fine. Denoted by symbol this. So for potential difference, the SI unit is volt, and for current it is ampere. How to define the unit of resistance? The resistance is said to be 1 ohm. Fine. If the potential difference across the two ends of the conductor is 1 volt and the current through it is 1 amp. Fine. This is how we can define the unit of resistance. Clear? Is that clear, everyone? Okay, so let's recall all the points that we have studied today. Fine. Starting with the concept of electric potential. Fine. Potential difference is work done per unit charge in bringing work done in bringing a unit positive charge from infinity to that point. Fine. If you talk about two finite points means one point to another, that is the case of potential difference. Fine. So potential difference between the 2 points in an electric circuit is defined as the work done in bringing unit positive charge from one point to another. SI unit is volt. So how can we define the unit of potential difference? That is 1 volt. Potential difference is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb of charge from one point to another. Right? After that, potential difference is measured by voltmeter device called voltmeter. After that, we have some circuit symbols, that is for the cell, battery, plug, key, switch open and switch closed, wire join, wires without joining, electric bulb, resistor, variable resistor, ammeter, voltmeter, and galvanometer. Right? After that, Ohm's law, one of the most important laws. Fine. If you talk about Ohm's law, fine. Ohm's law states that the potential difference across the two ends of the conductor is directly proportional to the current flowing through the conductor. Right? So V is proportional to I. V is proportional to I. Fine. So if you put equality instead of this proportionality, we have to apply a proportionality constant. In this case, we have R, that is known as resistance. So resistance is the opposition offered by the conductor to the flow of charge. SI unit of SI unit of resistance is ohm. Fine. So 1 ohm is equal to 1 volt upon 1 ampere. Means to say resistance is said to be 1 ohm if the potential difference across the two ends of the conductor is 1 volt and the current flowing through it is 1 ampere. Now, if you want to draw a graph between V and I, means potential difference and current according to the law, they both are directly proportional. Fine. If you increase the value of potential difference, then the current will increase. The straight line gives the constant resistance. Right?